Hello viewers, in today's session we are going to discuss an important and conceptual problem from definite integrals. So here we have to evaluate this definite integral in which the limits are from 1 to 2 and the integrand is x plus 3 divided by x square plus 4x plus 6 raised to 3 over 2. So here we have in the numerator a linear function and in the denominator we have a quadratic polynomial raised to some fractional power, right? So in these type of integrals what we do, we take this term, that is the square term, that is x square, common from this quadratic function, right? So let us call this integral as I, and let us take uh, x square common from the denominator, right? So we can now write here x square, and then we have 1 plus 4 over x plus 6 over x square, and here we have the power that is 3 by 2, right? So the purpose of taking x square common in the denominator is that this 2 and this 2 get cancelled here, and we can write this integrand as x plus 3 over here we have simply x cube, because x square raised to 3 over 2, 2 and 2 get cancelled and we have x cube, right? So here we have x cube, and now we have 1 plus 4 over x plus 6 over x square, and here we have 3 by 2, right? So now we can make use of the concept of substitution. So now let us take u square equal to 1 plus 4 over x plus 6 over x square, right? So here I will make this substitution, that is u square is equal to 1 plus 4 over x plus 6 over x square, because when we take u square over here, then see what we get. We have u square raised to 3 over 2, so this 2 and this 2 get cancelled and we are left with simply u cube, right? Okay, now let us differentiate both sides with respect to x. So we have here 2u du over dx, and the derivative of 1 is 0, and then we have the derivative of 1 over x as minus 1 over x square, and here we have 4, and here a 1 over x square has the derivative minus 2 over x cube, right? So now we have 2u du over dx is equal to minus 4 over x square, and here we have minus 12 over x cube, right? So now let us rearrange the terms, and let us first divide both sides by 2. So we have u du over dx, and here we can take negative sign outside, and here we are left with 2 over x square, and here we have 6 over x cube, right? Okay, now we can further write this term as a negative, and here we can take the LCM of x square and x cube, and that is x cube. So here we have 2x, and then we have simply 6. So now let us further write this term as minus, and here we can take 2 common. So we have x plus 3 divided by x cube, right? So here we have obtained this term, that is x plus 3 over x cube. So now we can write u du, and we can take this negative 2 in the denominator here, and we can now write x plus 3 over x cube, and here we can write dx, right? So now x plus 3 times, here we have dx over x cube. This term is now equal to u du over minus 2. So now let us change the limits accordingly. So here we have x is equal to 1 to x is equal to 2. So when x is equal to 1, we can obtain the value of u square by taking x is equal to 1 in this expression. So we have 1 plus 4 plus 6, because here we have 1 and here we have 1 square. 1 square is 1. So this is 6 plus 4, 10 plus 1, 11. So u is equal to square root of 11. So when x is equal to 1, u is equal to square root of 11. And similarly, we can find out the value of u when x is equal to 2. Right? So u square is now equal to 1 plus 4 over 2 by taking x is equal to 2 in this expression. So we have 6 over 2 square. 2 square is 4. So let us add these terms. So here we have 1 plus 2, then here we have 2 times 3, and here we have 2 times 2. So this is 3 times 2, 6, and here we have 3, and this is 2, so this is 9 over 2. Right? So the value of u can be written as square root of 9 over 2, that is 3 over square root of 2. So when x is equal to 2, we have u is equal to 3 over square root of 2. So now let us express this integral in terms of u. So now the limits goes from square root of 11 to 3 by square root of 2, and for this term, that is this one, we can now write x plus 3 over x cube dx as u du over minus 2 divided by this term can be replaced by u square. So here we have u square raised to 3 by 2. Right? We can take minus half outside the integral, and we have square root of 11, and here 3 by square root of 2, and now we have u du, and in the denominator this 2 and this 2 get cancelled, so we are left with simply u cube. Right? So this is minus half and square root of 11, 3 over square root of 2, and here this u get cancelled, and here we are left with du over u square. Right? So now we have a very simple integral, that is du over u square. So by the method of substitution, we have reduced this integral to this simple integral, and the integral du over u square is minus 1 over u. Right? So now we can write the integral I as minus half, and here the integral du over u square is minus 1 over u, and the limits of integration are from square root of 11 to 3 over square root of 2. Right? So now this negative sign and this negative sign, when multiplied together, it will give us simply a 1 over u, and here we have square root of 11 and 3 over square root of 2. Right? So now we can simply substitute the limits and we'll take the difference. So we have 1 over 3 by square root of 2 minus 1 over square root of 11. Right? So we have 1 over 2, and we can take square root of 2 in the numerator, and here we have 3, and here we have minus 1 over square root of 11, right? So multiplying these two terms by half, we can now write root 2 over 6, and here we have 1 over 2 times square root of 11, right? So now we can rationalize this term by square root of 2. So we have simply 1 over 3 times square root of 2 minus here we have 1 over 2 square root of 11, right? So the value of this integral is given by this expression, that is 1 over 3 times square root of 2 minus 1 over 2 times square root of 11. So viewers, this is how by making use of the concept of substitution method, we can easily find out the values of these kind of integrals.